Hi, this is Aaron Holmberg at Corvallis Middle School, and this is a video designed to teach several key ideas for students as they understand finding the volume of rectangular prisms like we see in this picture here. What I'm going to show is not all the answers for this worksheet, but I'm going to show some of the maybe key difficulties or key strategies that students ought to be using to help themselves understand how to find volume of these shapes. Okay, so the first one I want to show is just this concept. You can see here that this is a hollow model that I have in my hand, and one error that sometimes students will do is that they will think that this model they see right there is actually a hollow object, that they're only counting the cubes that they can see on the surface of it, but it's not. It's when they look at it, it's actually more like this Rubik's Cube. It's got it all the way around. And of course in class we talked about how if you know how a Rubik's Cube is built, it's hollow in the center. It actually is missing one of the very centers. These all joined. But it makes you think that it's a layer. It's 3 layers of 9. Like this would be 9 and 9 and 9 in each layer of the cube. So anyway, that's one common mistake. One common thing that I teach in class is that I ask students to look at a graphic like this or any of these particular graphics, find a corner that they think is sort of sticking out at them, and make a dot there, and then draw trace down the edges of that prism, and know that those are the 3 dimensions that they need to find. And no matter what kind of graphic you're looking at here, if you work like this, then it helps you be able to search out a missing dimension, for example, and it helps you remember that it's got to be 3 dimensions that you're multiplying. I have another thing. I took a Lego and I showed just kind of how this works on a piece of Lego, so that you can see the dots in black there, and then these lines are going out the same direction. And this, by the way, just shows a model of how 2 volumes can be joined up and how you would find them. I'll show this a little bit later again. The next most common error on a graphic like this is that students will improperly count the sides of it. So they just need to be really careful. 1, 2, 3, 4, 5, and they can label 5. Whoops, not a very bright pen here. They can label 5, and they should know that, of course, that is the same as that top edge, and the graphic sort of proves it. Most 5th graders get that. When it's turned sideways like this, it's kind of surprising how many students have trouble counting when it's turned in this little angle like that. So again, they just need to touch those spaces, 1, 2, 3, 4, and then write 4 on that side. And then going up the side, they need to remember to count every block twice. They can't start here like this at 1. They have to start at the corner because they're actually counting the length of the side. 1, 2, 3, 4, 5, and they should list them. By doing that, if you start by really making notes on the diagram, then you can get everything else, like if you're finding volumes or this sort of thing. It's a lot easier to work with that. Okay, the second section of this is one that is challenging for some students, and I'm just going to show what some of the work can look like before I get there. Students should be trying to do something like this, and again, in these models here you can see how the dots are on these corners right here, and I've found 3 dimensions that I'm looking for. One of the common errors that's come up in class, or one of the common questions, is when students first see this, they're not exactly sure what the length of the side is, and they'll question, am I supposed to assume that it's 3? And the answer is yes. That's the way this particular graphic shows it, that would be 3 layers, and this would be 2 layers, and so forth. So your dimension on this side would be 3, your dimension on this side would be 2, even though it's not labeled. So that's kind of a key piece there. I want to go backwards then, though, and show one idea that students struggle with, and it's in understanding a graphic like this. If they need to find the length of, say, let's put the line here and make this red, and they need to find this volume here, and they don't know how to find that side there. They know this is 3, and they're not sure what this side is, and they're not sure what that side is. That's where they often struggle. And so we spend time in class really trying to understand this. This length 2 right here is kind of floating in outer space, but it's the length of this side. Okay, and the length of that side plus the length of this side equal this 5 sitting over here. And that's just, it may look sort of obvious, but it's sometimes really hard for students to process that sort of graphic and to understand that on every rectangle, one side is exactly congruent to the other side. It's true of rectangles always. So if that's 2, then what makes the 5? 3 down here, and so you've got your other dimension is 3. And that is kind of tricky for students, being able to see that. Likewise, this one actually shows the 2 in the bottom, so that one's pretty easy. So there are several here that are forcing students to do this, to recognize that if this is 2 and some other number, make the 4, well, it has to be 2 on this side. If this is 4 and this is some other number, those 2 things combined make 9, so that would have to be 5 right there. And that would have to be 5. This is 4 and that's 4. This is 2 and that's 2. This is 2 and that's 2. That's a really key thing for students to do and to understand a graphic like this.